Position is location of a particle in space. So where can we find that particle? In one dimension, we usually just represent that as some type of position x. Now we could go two dimensions, right? So if I'm thinking of the floor you're at right now, we can go ahead and say that maybe the so position. That is where if we're going to start our one-dimensional motion, first we just have to give what is our basic position. It is where we are in space. So if we're in one dimension, think of like a number line, we can just call that position x. And so how many spaces we move forward or backwards. If we have two dimensions, x and y, so if you think of your graph, or if you just think of the ground, you're in one corner, I can move like 3 steps over laterally, then maybe 2 steps forward, right, to be in a 3-2 position. And then we can always go 3 dimensions as well, right? So if I did that and then I move up in the air, that would be my third dimension. Now, we're mostly going to stick to one dimensions in here for the most part. And so once we have a position, then we can go ahead and figure out a distance. So a distance is the relationship between two positions. So the total length of the path traveled by an object going from one position to another position. Okay. Distance is just the total path traveled. We really don't care about direction, right? It's just how far have I walked. So if I take like 4 steps forward, 5 steps back, I say, what's the distance traveled? I want 4 plus 5, that's 9. All right. So if I have a one-dimensional coordinate system right here, so this is 0, 1, 2, 3, and then here's my negative. So a negative in physics just means we're going backwards. All right. Negatives in anything, right, is just when you're moving the opposite way. That's all really negative is telling us for the most part. So if I go ahead and say I'm at position 1, so this would be x equals 1 right here. This is my initial position. And then I go here. I go backwards, 1, 2. Well, what's my distance traveled here? My distance is I just took 1, 2 steps, right, or 2 meters here. There's measurement in meters. So I can go ahead and say the distance moved by a particle is 2 meters. Again, I don't care about direction. I just care about the total path traveled. Now, there are times, though, where we do care about direction. We want to account for that. So in order to do that, we introduce this new term here called displacement. Displacement is very similar to distance, but it is different in that we care about the direction. So it's the change in position of an object depends only on the initial and final position, not on the path. This does include direction now. Okay, how far are you from home? How far are you from your original spot is another way to think of this. All right. We've talked a little bit about scalars and vectors. Remember, scalar is a magnitude that does not care about direction. Well, a vector is something that does, all right? We talked about Despicable Me. You got the bad guy named Vector. He's Vector because he's got magnitude and direction. And that's what displacement is. This is our first actual vector that we're dealing with here. So we do care about the location and the direction for displacement. We can represent it by the equation of just the change of x. And it does have a direction. So this is called delta right here. Delta x, or delta represents the change. And that's going to be x final minus my initial x. So my final position minus my initial position. So if I walk 4 feet forward and then I come back 2 feet, my total distance in this case, so I'm not talking displacement, I'm talking distance. My total distance is 6 feet. But what's my displacement now? Well, I went 4 feet forward, and then I came back 2 steps. So from my original spot, okay, my original spot I'm saying is 0, and then my final spot is 2. So 2 minus 0, that's 2. I moved 2 feet, and I also now have to include a direction. So I say 2 feet forward. Displacement is really important, especially when we're talking about directions, right? If you're talking to a friend, and they say, hey, how do I get to the store? And they say, you just got to go a mile. You don't just start moving, right? You say a mile in which direction? A mile where? A mile can mean a lot of different things. Displacement is giving us that relationship to where. Okay, so if I go back to that example we saw here, if I start at x equals I here, and I want to go ahead and find my displacement. Now, we already said my distance is just 1, 2, right? 2 meters. My displacement, though, I take my final position, -1, and I subtract my initial. So -1 minus 1. Well, that's going to give me a displacement of -2 meters. Okay, so by taking that final position, -1 right here, subtracting my initial, is just then gets me -2. So they're very similar, but there is a big distinction between these. Distance just tells us how far we've gone. Well, displacement says how far we are from our original spot. So a really common way to describe these two is if I'm in, say, on a track, and I'm going to go from position A, and I'm going to go all the way around the track to position B right here. Okay. Well, if I'm thinking distance and displacement, what's my distance? Well, it's the path I travel along this right here. So that might be 100 meters going around my path. My displacement, though, is just the difference between these two, right? So if I'm thinking this as, maybe I'll say this is 2 dimensions right here, right? My x isn't changing. I haven't moved laterally. But my y goes up about 50 meters here. So my displacement is just 50 meters. That's how far these two positions are apart. Now, I didn't go that way, but that's where I am. Another example I really like to think about this is if you walk in like a city, right? If you're in a city and you have to go a couple blocks away, you might have to take a couple turns. Your distance is what you're actually going to have to walk, right? Because you're going to have to go around city blocks. You can't go through buildings. The displacement might be the actual distance between the two things, though. And just because it's maybe a short distance, it might take you a long time to have to get around. Maybe there's traffic or whatever's going on. All right, so let's just look at one example of this. Maria is at position x equals 23 meters. She then undergoes a displacement of -50 meters. What is her final position? Well, if I'm thinking of this as a number line, right? She's 23, and then she moves backwards 50. Well, if I split, I'm going to split 50 into 23 and then 27, right? Because 23 plus 27 gets me 50. So she's going to go ahead and walk 23 steps backwards, and that's going to put her back at 0. And then she has to keep going -27 meters here. Okay, to go that total displacement of -50 meters. So we're going to do some practice problem. Hopefully that makes a little more sense just on distance and displacement and the difference between those two. I'm going to have another video up here. We're going to go over those practice problems we did, making sure you understand and can calculate the difference between distance and displacement.